What is momentum? Momentum is a quantity of body. It is a product of mass and velocity. So momentum we can denote it by P vector, that is equal to mass into velocity. That means it is a product of momentum, it is a product of mass and velocity, and also it is one of the quantity of motion in a body. Just remember, P vector is equal to mass into velocity vector. So this is the definition of momentum. Momentum is always directly proportional to the mass, and momentum is directly proportional to the mass as well as velocity. So then if you remove the proportionality constants, this is the proportionality constant, if you remove the proportionality constant, we will get m into v vector. So this is the expression for momentum. And for example, when it is directly proportional to the velocity, the cricket ball moves with the different velocity. You just look at this example. So this is tennis ball and this is a cricket ball. Suppose if I want to apply a force on this balls will move with a different velocity. Then the momentum of the ball with a greater velocity possesses more momentum. So this is one of the example. When the body is at rest, the velocity is 0. Suppose if the ball is at rest, the velocity is 0 as well as the momentum is 0. As well as the momentum is also 0. So but every moving body possesses momentum. Either the body is at rest, it cannot possesses the momentum, but the body is in motion, it will possesses the momentum. So this is the definition of momentum. And momentum is a vector quantity. It is not a scalar quantity. Scalar quantity means it has only magnitude, but momentum is a vector quantity. Vector quantity means it has both magnitude and direction. So the SI unit of momentum is P vector is equal to mass into velocity vector. So what is the SI unit of momentum? Mass means kg, velocity means meter per second. So the SI unit of momentum is kg meter per second. So this is the definition and this is the concept, very important concept of momentum. The man is drilling the stone. So this shows that the above example, this example shows the momentum is a vector. Suppose the stone is drilled with a uniform speed in a horizontal circle. See, this is drilling the stone in a horizontal circle by means of a string. This shows that momentum is a vector. So when the man is drilled with a uniform speed in a horizontal circle by means of a string, this stone shows the momentum is a vector. Then the next point is the magnitude of momentum is constant, but the direction keeps changing continuously. See, the man is drilling in a circle, okay, but the direction is changing here. When the stone comes here, the direction is changing like this. When the stone coming here, then again the direction is changes continuously. Means the magnitude is changing continuously and its direction keeps changing continuously. The magnitude of the momentum is constant, but the direction is continuously changing. And the next point is the force is needed to change this momentum vector. And the force is provided by the hand through the string, it also felt by the hand. So this is one of the very good example for momentum when the man is drilled in a circle by means of a string. This is very important example. The next topic is Newton's second law of motion. What is the statement of Newton's second law of motion? It is the rate of change of momentum is directly proportional to the applied unbalanced force and it acts in the direction of force. That is the Newton's second law statement. So this force is directly proportional to the change in the momentum divided by time taken. So, this is the derivation of Newton's second law. Derive an expression for force F is equal to mass into acceleration by using Newton's second law. So, this statement refers to the Newton's second law, that is F is directly proportional to the rate of change of momentum. So, this is the expression. Here F is the force and V is the velocity of the body, mass M is the mass, and dP by dt or del P by del T is changing the momentum. So, this refers to F is directly proportional to del P by delta T. Remove the proportionality constant. So, F vector is equal to, that proportionality constant is K del P vector by delta T. So, this K is a proportionality constant. Then we can also write this expression in the form of limitation. So, that refers to limit of delta T tends to 0 del P vector by delta T. So, this limit delta T tends to 0 represents the instantaneous velocity, or we can also write this expression F vector is equal to K into dP vector by dt. So, then what is P vector? We know the definition of momentum. P vector is equal to mass into velocity. So, P means mass into velocity, then vector F is equal to K into, you can take M outside, then the remaining thing is dV vector by dt. What is the rate of change of velocity? Vector F is equal to K into acceleration. So, dV vector by dt is acceleration. The final expression is vector F is equal to mass into acceleration. This is the very important derivation for the board exam 5 marks question. Derive an expression for force is equal to mass into acceleration by using Newton's second law. The Newton's second law is vector F is equal to K into mass into acceleration. So, what is 1 Newton? What is 1 Newton? 1 Newton means when the force applied on a body with 1 mass kg produces an acceleration of 1 meter per second square, that is called 1 Newton. So, that is you can just apply m1 and acceleration is 1, then force is also 1, then what is the answer? 1 is equal to K into 1 into 1. So, what is the answer? K is equal to 1. So, what is the proportionality constant in Newton's second law? The proportionality constant value is 1.